So let's investigate the side, side, side similarity shortcut. Okay, so for side, 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 we're going to start again with a triangle. We'll call it ABC. Nothing special needed. Maybe I'll make it look a little bit different. What if I did like an obtuse? Something obtuse maybe? All right, so once again, we'll just call it ABC. For my side, 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 what I'm going to do is I'm going to predetermine a scale factor. And usually a scale factor of 2 is like the easiest one to do. Sometimes a half is a really nice one to use. Other scale factors, they're just really tricky to do. So remember, all we're doing here is copying the sides, and we don't want to copy any angles here. So what I'm going to do is redraw each of my segments, AB, segment BC and segment AC. I'm going to draw them down here, and then I'm going to try to construct my triangle over here. But I'm going to do it with a scale factor of 2. So this is going to be my new segment A prime, C prime. This one's going to be my longest segment, so I should really have an actual straight edge for that. But, all right, this is going to be my A prime, B prime. And then this is going to be my B prime, C prime. I might need more space. Well, we'll see. Well, this one is a lot of work, I will say, everybody. So it's okay if you just maybe follow along with me instead of having to do it. Okay, so there's AC. I'm going to copy that twice. And that's going to give me A prime, C prime. AB. Here's A prime, B prime. Again, I'm using a scale factor of 2. And then here is B prime, C prime. So our goal is to create a triangle with these 3 segments. And then we know the segments are proportional, right? We know the sides are proportional. So what would be the other thing that we would have to include in our similarity idea? It would have to be, of course, that the angles were congruent. So let's go ahead and then create a copy. So this is going to be a fairly large triangle. Okay. We'll start. I hope we can see this. There we are. So what I'm going to do is redraw a very long segment, and actually for A prime, C prime, instead of me copying that, because I actually do not think my compass will open up that wide, I'm actually just going to recopy it twice. I think that might be just the easiest thing to do there. Okay, so then with A prime, B prime, that I can open up my compass. This should be fine. Right, okay, so there's my compass at that setting. Then to get my copy, I put my stylus on A prime, and I swoop over here where B prime is going to be somewhere along that arc strike. So then for B prime, C prime, I go, oh, it's hard for you to see, sorry. I go back to my segments, open up my compass to B prime, C prime. And then I put my stylus on C prime. and copy that length. And that's where I believe, well, not I believe, that's where I know B prime is going to be at that intersection point. What we want to check is angle measures. We can go ahead and check our angle measures for our newly created triangle by either taking some patty paper and copying those angles and then checking them, or you could of course take your protractor. I think it's a little bit more work to measure with a protractor. So I'm just going to create a quick copy. And, oh, it was hard for you to see that. All I did was trace that. Apologies, that wasn't in the screen. Okay, here we go. Is B prime congruent to angle B? Yes. Is A prime congruent to angle A? Yes. Is C prime congruent to angle C? Yes. Do I have similar triangles? Yes. Okay. And so then our last one is side angle side. So here's what I want you to imagine. We are going to take triangle ABC, this triangle here. I'm not going to draw a new triangle. And we are going to think about if I have segment AC, and I copy it twice like I did here to create segment A prime, C prime. And then I copy angle A on there. And then finally I copy A prime, B prime. Do you think I'm going to get a similar triangle? What would have to be true then? Well, B prime, C prime would have to be the same length as my B prime, C prime I just produced. And then angle B and angle B prime and C prime would also have to be congruent to original triangles B and C. Do you think that's going to happen? I am going to pause the video. I'm going to create the triangle so you don't have to watch me create it, and then we'll check that. All right, restarting this video. I copied A prime, C prime. I copied angle A. And then I copied A prime, B prime. You can see there was the one I just did, so I'm not reusing that. I'm making a new one. And now all that's left to do is connect B prime to C prime and check those angles. Okay, checking the angles with my patty paper copy. Well, there we go. B prime and B, angle B, same measure. C prime and C, yes, same measure. Now, let's check. Is segment BC twice the measure of, is segment B prime, C prime twice the measure of BC? Let's go ahead and check that out. Okay, here we go. 1, 2, it is. All right, so this was our side angle side. Yes, also a similarity shortcut. Let's wrap up this part of the video, and then we'll go on to some follow-up questions and examples in video 3. So, angle, angle, angle. If two angles of one triangle are congruent to two angles of another, then the triangles are similar. Side, side, side. If three sides of one triangle are proportional, remember not congruent, but proportional to three sides of another, then the triangles are similar. Side angle side. If two sides of one triangle are proportional to two sides of another and the included angles are congruent, then the triangles are similar. Is side, side angle a similarity shortcut? No, and it's the same reason it's not a congruent shortcut. It doesn't work all the time. This was because depending on how that non-included angle was created, there were two options for that segment to occur at that same length. And that would be true of similarity. Like the segments aren't going to be the same length. They'll be proportional, but no, it will not produce similarity all the time. Okay, and how did the similarity shortcuts compare with the congruent shortcuts? Well, it includes all the congruent shortcuts plus an additional one. So all congruence shortcuts are similarity. However, we have an additional one with the addition angle, angle, but remember, angle, side angle, and side angle, angle collapsed. So you could technically still have these if you had that knowledge, but you could just collapse it to angle, angle. I'm going to stop this video here, and then what I want you to do is do these examples and then start the third video to look at and check your answers on the examples.